Missiles are meant to deliver an explosive warhead with pinpoint precision at high speeds. Missiles range in size from small tactical weapons, with ranges of only a few hundred feet, to considerably bigger strategic weapons with ranges of thousands of miles. Over the last 4 decades, India has quietly improved its missile program, mostly via its own efforts. Today, India has built, tested, operationalized, and is developing a variety of missile systems that are exclusively available to a few countries, including ICBMs, ASATs, SLBMs, and hypersonic weapon systems. The usage of rockets for warfare in India goes back to the 18th century. Mysorean rockets were the first iron-cased rockets to be effectively deployed for military usage. They were reverse-engineered by the British and presented in Europe as the Congreve rocket. India lacked domestic missile capability at the time of its independence. The Special Weapon Development Team was founded by the government in 1958. Later, it was made larger and given the name Defense Research and Development Laboratory. India's missile arsenal serves a number of defense objectives. It particularly supports New Delhi's nuclear deterrent posture toward its main enemies, such as Pakistan and China. Project Devil was started in 1972 to create a medium-range surface-to-surface missile. Dr. APJ Abdul Kalam created the Integrated Guided Missiles Development Program in 1982 to help India become self-sufficient in missile technology. The fundamental technologies required for a missile program were available between 1970 and 1979. To develop a rocket engine driven by liquid propellants, a second project dubbed Project Valiant was also started. The objective of Project Valiant was to build an intercontinental ballistic missile using a liquid propellant rocket engine. The inertial navigation system was a crucial component of a long-range missile, hence Indian scientists focused on developing a guidance package. By the beginning of the 1980s, DRDL had gained expertise in the fabrication of materials, navigation, and propulsion systems. As a result, the Integrated Guided Missile Development Program was created. And Dr. Abdul Kalam, who had previously served as the SLV-3 program's project director at Indian Space Research Organization, was appointed as the DRDL director in 1983 to conceptualize and oversee it. He made the decision that DRDL would work on several initiatives in this area at once. These are the 4 initiatives that emerged from the Missile Development Program. Short-Range Surface-to-Surface Missile, codenamed Prithvi. Short-Range Low-Level Surface-to-Air Missile, codenamed Trishul. Medium-Range Surface-to-Air Missile, codenamed Akash. And Third-Generation Anti-Tank Missile, codenamed NAG. India's civilian satellite program was the forerunner of its ballistic missile program. The fact that Indian scientists were already experienced with solid rocket propulsion systems intended for propelling payloads into low-orbit or suborbit configurations made it simple for them to convert the launch vehicle into a short-range missile with a constrained payload. In the case of India, the connection between satellite launches and ballistic missile development is more visible. Through common R&D and production facilities, the space program aids New Delhi's missile operations. The creation and design of the Agni missiles marked the first direct technological fusion. Agni was a 2-stage rocket that used the SLV-3 as its first stage that was started in 1979, the same year that India launched its first SLV-3. The Agni missile system plays a crucial role in India's capacity to resist second strikes, particularly against China. Solid-propelled ballistic missiles, with ranges between short-range and intermediate range, make up the Agni missile category, with road and rail mobility providing greater chances of survivability during an enemy attack. This strengthens its scope of launching a counter-strike. After the Agni, the development of the shorter-range Prithvi missiles began. The Prithvi program, a road-mobile liquid fuel missile, commenced in 1983 and was first tested in 1988. The Prithvi is designed and developed entirely in India. India now has a stockpile of powerful ballistic missiles, notably the Agni series. While Agni 1, Agni 2, and Agni 3 are older generation, Agni 4 and 5 are more technologically advanced. The freshly tested Agni P also boasts more sophisticated technology than previous models. The Agni 5 and Agni P are integrated with DRDO's multiple independently targetable re-entry vehicle technology. India also has advanced missile systems, such as the Akash surface-to-air missiles, NAG anti-tank guided missile, Astra air-to-air missiles, BrahMos supersonic cruise missiles, underwater-launched K-15, and land-based Shurya missiles. In addition, India possesses ballistic missile defense systems, known as Prithvi Air Defense. However, missile development in India has been a story of self-reliance and perseverance, with pioneers facing technology denial regimes, such as the Missile Technology Control Regime. Because countries such as India were rapidly developing and testing advanced missile systems, during the 1980s, an informal grouping was formed in 1987 by Canada, France, Germany, Italy, Japan, the United Kingdom, and the United States to restrict access to any technology that could aid India's missile development program. Following the launch of Agni in 1989, the United States refused to provide India with phase shifters for Akash SAMs, phased array radars. The supply of computer processor chips, radio frequency devices, electrohydraulic components, maraging steel, magnesium alloy, gyroscopes, accelerometers, carbon fiber, glass fiber, and other components to India has been halted. Due to the MTCR restrictions, India was refused the purchase of an Arrow 2 theater missile defense interceptor from Israel for its ambition to create an indigenous ballistic missile system. The system, which was developed jointly by the United States and Israel, must be approved by the United States before it can be sold to any other country. To counter the Missile Technology Control Regime, various Indian defense institutions collaborated with public and private sector industries, as well as academic institutions, to develop maraging steel for rocket motors, carbon composites and resins for the Agni missile's re-entry vehicle, magnesium alloy and phase shifters for Rajendra radar for the Akash missile, winding machines, and so on. Despite the fact that this hampered the program's development, India successfully built all of the limited components denied to it by the MTCR on its own. And now, India's strategic missiles had advanced to the point where no technical control regime could derail them anymore. India can make the most destructive and powerful missile systems in the world, including anti-ship missiles, air defense systems, ballistic missiles, cruise missiles, air-to-air missiles, various anti-missile systems, and anti-submarine torpedoes, as well as the capacity to attack targets in space. Thank you for watching Athena Defense. If you liked the video, please give it a thumbs up and support my channel by subscribing.